My name's Steven Chin. I work for Oracle as a Java evangelist. You can follow me on Twitter at SteveOnJava.
And my name is Andrew Phillips. So I work for a company that's not mentioned here, ZBA Labs, do deployment automation, but I spend too many evenings and early mornings working on JClouds, which is an open source Java cloud library.
And we're gonna show you guys the combination of some technologies you might not traditionally think as being a match. JavaFX technology, which is a rich client user interface technology. Scala, which is a JVM language that many people love. Some are proficient in. Very few are proficient in. I'm not proficient in. And the cloud.
Which is a lot of hot air, literally.
So what do we get? We take JavaFX, Scala, and hot air. Obviously, we need a sound effect for this.
Something like that.
Thank you, Andrew.
No,
so we don't really get that. That's not life. But maybe we get a cool conference app. Maybe. We'll see. We'll see if we can make something come together. All right, so the way this talk is arranged is we're going to introduce these different technologies, show you guys hopefully something new you don't know about each of them, and create an application with an architecture that looks kind of like this. So we'll have a cloud. We're going to use Amazon EC2 or Amazon S3 in this case, their storage engine. We're actually going to have a cached database file in the cloud. It's not a cloud DB, it's just a cached database file. We're going to use JClouds, which is a Java API for accessing different clouds. It's a kind of a cloud agnostic. What should we say about JClouds?
I don't know. I like to think of it as the kind of JDBC for cloud stuff, because the idea is to abstract away the individual things of individual cloud providers and to give you portability, but we'll talk about that.
And JClouds works really good from Scala. So this entire application end to end will all be written in the Scala language. For the application, we're going to have Derby, or JavaDB, which is an embedded, you can either run it network or embedded mode. We're using it as an embedded database, very lightweight data store, which is going to be inside of our JavaFX application. And we're using ScalaFX, which is a Scala binding for JavaFX. So it's all end-to-end Scala. Circumflex is the one of the many ORM frameworks, object relational mapping frameworks for Scala.
See, the good thing is about the new language, like Scala, you get to reinvent every possible wheel that there is, including ORM and everything else. And then you have like a million things to choose from, like you did at the beginning of Java, and eventually that'll all crystallize out. But, you know, yeah, the Wild West is a fun place to be.
All right, so when does this architecture actually make sense? So we're kind of, for this application, we say that this is an efficient architecture and this makes sense. But this sort of cloud storage of a cache DB doesn't always make sense. So when does it make sense? If your data is mostly read-only. So in the case of the conference application, the assumption here is we have a large set of data. It doesn't update all that frequently, maybe a couple times a day at most. And we don't really have a lot of updates going back to the server. If we had a bunch of updates we need to synchronize between different people, we'd probably want to take a different approach or augment this with a REST interface in addition. And also, this approach, since you're actually moving all of the data to the client, it assumes small to medium data set size. Now, about 10K records is where this starts to break down. If you have a big data set, you're not going to want to take an approach like this. But this is not the total DB size. So, for example, one of the applications I worked on recently was for a huge data catalog. Retailers could see the whole data catalog, so they're obviously not going to want to download it bit by bit like this. Vendors could only see their data. So it would be quite reasonable for them to actually have a full view of their data cached locally and operate on that, and then synchronize it with the cloud periodically. So our conference app has 3K records, and these are relatively large records, full session titles, speaker bios, etc. And it compresses down to 330 kilobytes for a full database, just standard zip compression. You could probably get better if you used a better performing zip algorithm.
And let's remember, not too long ago, that was the entire amount of memory that you had available on all your portable devices. So we're lucky we're in the future.
Yeah, we're talking about modern.
Yeah, no, I know, modern. It's like, oh, out of memory, more than 72K use. Anyway.
Yeah, modern phones. My first computer was less powerful than this. So okay, so that's when it makes sense. Now let's talk about why you'd want to do this. So some of the advantages of this are offline operation. Once you've sucked down your cache DB, either as part of your application or kind of an initial cloud pull, you can operate completely offline, do filters, queries, anything you want to against the data set, and it's fast and local. Very responsive, since all your DB queries are local. You don't actually have to wait for any server hits on page reloads or refreshes or paging through data. And you get extremely high availability and scalability basically for free. Amazon S3 is designed for about, what was that, 4 nines? 99.99% availability, which is pretty good. You'd have to actually spend good money if you wanted to get that level of reliability in your own architecture. And it easily scales up to hundreds of requests per second with no effort. If you're careful about how you do bit hashing in S3, you can scale it up to millions of requests per second. Anyone curious about how bit hashing works in S3? Okay, let's slight digression. So the way S3 is composed is it has a bunch of storage servers. And when you initially create a new bucket in there, it gets allocated on usually one of their storage servers. And each storage server can easily handle hundreds of requests per second. It's not going to give any hiccups. But then when you start going like 1,000 requests per second on a single server, your performance is limited, although they have thousands of these storage servers. So you obviously don't want all your data sitting on one server. So if you're careful with your file names for how you store things in Amazon, basically their hashing algorithm works off the name of the file. So if you name your files in random spots in the ASCII range, first character, second character, third character, you will get your data partitioned across multiple servers, giving you much, much higher throughput than you could get on a single Amazon S3 instance.
That would mean name of the blobs, I take it.
Yeah, the blobs. So anyway, little bit of trivia, but with proper use of S3, you can scale up to even better than hundreds of requests per second.
Just a curiosity thing from my side, is that something they guarantee to support over time, or is this just abusing an implementation fact that we have to know?
No, well, it's been documented by the S3 folks. Originally, it was part of their professional support program, but they've actually talked about it in public. And the people initially reverse engineered it, but at the point at which Amazon announced and started talking about it, people essentially build applications against S3 this way now. Okay, anyway, a little bit of trivia about S3. So the last advantage, and some of us have budgets, is cost. How cheap is it to build applications like this? So 3,000 users with our 330 kilobyte data model, it's free. Up to 1 gigabyte in Amazon, 1 gigabyte of outbound traffic per month, and you're in the free tier, so that's great. We like free. So 10,000 users would cost you 28 cents a month, which is about a pack of gum. So if you have a moderate traffic application, think about a conference. If we put the conference application out for like JAX, we're probably not going to exceed 10,000, I don't think.
But we're still short 1 pack of gum.
Now you can scale up to 100,000 users. How many people have web applications, which serve 100,000 users here? Okay, so you probably, but for your company, yeah. Okay, I mean like 100,000, you're actually getting to real corporate business applications, and so a cup of coffee. How much does your company spend on serving costs? About a cup of coffee?
How much does your company spend on coffee?
Probably a lot.
Probably a lot,
soda.
Yeah. Especially if it's a nice brand name coffee.
Good perks. Okay, and then, a million users, which you're getting to the insanely scalable size, your, copy of a video game. I'll play any of you and take you down to StarCraft if you want. That's about the only video game which I actually am somewhat competent at. So, I mean, this is assuming you have the 330 kilobyte data size for about the size conference app. If you have a larger application, your scalability will be different based upon the size of the data you're storing in the cloud, and also depending upon the frequency of updates. Every time you push an additional update out, people are going to download more data, so you'd have more S3 costs. But you can see that this is relatively cheap backend for applications compared to setting up any moderately sized compute resource for actually doing a REST interface or some sort of processing. You'd pay, several orders of magnitude more in serving costs.
So basically, your users pay for the computing power by buying the phone that they
this is the green architecture.
Yes.
We're saving on computing and server costs. All right, so let's show you guys kind of the different components of the application. So we've got from the big architecture, we've got the user interface. So I think this is all me.
Da-da.
And we'll talk a little bit about the database, how we hooked up the ORM, and then cloud.
I'll talk a bit about the cloud.
And then we'll show you some of the code. The whole code for this application, I think I counted it over the weekend, and it was under 200 lines of code. So, a simple application, but it gives the idea that using technologies, Scala, JavaFX, and JClouds, you can write real applications with very, very little code. It makes your code efficient and maintainable. All right, so JavaFX 2.0, this is the what is JavaFX 2.0 slide. Rich client framework, cross-platform animation, video, integrate with web, HTML technologies, 2D acceleration, and some 3D graphics. It uses the Prism pipeline, which gives you excellent graphics performance on your client, and your favorite IDE, NetBeans Eclipse IntelliJ. And I should also comment on why JavaFX in this particular use case. So one of the attributes of a cloud computing model is typically what you'll do is you'll pay by usage. So you're either pushing out, in this case, storage, or in other cases, your computing costs to the cloud, and you're paying by how much you actually utilize those services: memory, storage, bandwidth, and CPU. With JavaFX, this is a client stack. All of the processing happens on the client. You're doing a lot of you can code Java and a lot of the business logic directly on the client. You can use local databases, local storage for caching results and doing things on the client. So what it does is it pushes a lot of those costs down to the devices, desktop or mobile devices. And you're taking your costs away. Whatever processing and network costs you can push down to the client reduces your cost of ownership as a cloud user.
Yeah, and if you don't want to tell your customers that you're just being cheap, you can tell them you're being green.
Yeah, green.
Because instead of warming up the environment, you're only warming up the customer's pocket.
Which, they're going to do that anyway, because they're going to play games on their phone. So they might as well put their processing power to good use.
Rather have Angry Birds or a real, well, I think they'd probably prefer Angry Birds, so let's not go into that. But for some use cases, it's nice to have a real app running on your phone. Anyway.
Okay, and this is the why Scala slide. So what's Scala, first of all? It's 2001, started in 2001 by Marty Nadersky. It's both a functional and an object-oriented language. It compiles to pure bytecodes. And in this case, we're using it as a straight substitute for Java. You could write the same application in Java. It wouldn't be 200 lines. It would be more like 1,000 plus. But you could do exactly the same thing with straight Java code, Java technologies. We're using Scala here as an accelerator to make the code shorter, easier, more maintainable.
Note that it is possible to have a pure object-oriented and also a functional language at the same time. I always love those two bullets.
Yeah, no, those are very historically very different language domains. I remember when I started on, a little segue, when I first became a Java developer. I was at Carnegie Mellon. I was working on a project called the Gwydion project, and we were building a interpreter and compiler for an Apple language called Darwin. Anyone heard of that?
Yep.
Okay, some people know about that. It was very cool stuff, and it was close to Java syntactically. Actually, on that project, we were focusing on tooling, so we decided writing a whole language just to get tooling working wasn't worth it, so we switched to Java. And that's how I ended up on Java. But at the same time, I was taking ML classes. ML is a functional programming language. And the guys on my project, these guys were Darwin Lispers or Darwin Javers. They just laughed at me. They're like, oh, that functional programming stuff, that'll never, completely impractical. It's not going to catch on. You can't write real apps with it. Blah, blah, blah. And, look at Scala. Object-oriented and functional on top of Java. Anyway.
Plus minus believing the various flame threads that are out there claiming that you can't do that. But let's leave it.
Okay, so some of the reasons why we like Scala. Static type checking. So some of us really like the Java compiler. It tells us when we make mistakes because we're not very good programmers. And Scala's great. It tells us like those puzzlers would actually fail at most of them. Well,
most of them. But
some of them.
But the reason the puzzles exist is because there's
closures. We don't have to wait till was it 2032?
Something like that. Java 9 or whatever.
I think it is Java 8 now, but yeah. Okay, and declarative. So you can express the UI by describing what the UI should look like. This in particular applies to the way ScalaFX applications look. And then lots of cool language features. Implicit conversions give you kind of this dynamic behavior like you would in a scripting language. Operator overloading lets you kind of redefine user interfaces, create DSLs, and deleted and net specialized are some cool little language features which I use in ScalaFX. So I punted on this yesterday. This is my last borrowed slide from yesterday's deck. Is anyone curious how these work, since I mentioned it twice, or you don't care?
Implicit conversions, by the way, is that one of the things I like about it, or in general, is that, of course, since it's a JVM language, ultimately you can do all this stuff, a lot of this stuff in Java.
All right, let's do that. I think that's more interesting. So, do you guys know how implicit conversions work in Scala, or what they are? Anybody? Yes?
You can put your hands up. You won't get shot. There's no sniper sitting in the back.
How about you? Have you ever seen what implicit conversions look like? Okay, so let me try explaining this. You help me.
Yeah, go on.
Because it hurts your brain a little bit to think about this. So one of the problems that implicit conversion solves is like in a language like Groovy, you just add methods. Like you could take the string class and you could just add a method. What's a good example of a string?
Of a string?
Like a string method we could add.
Oh, I know. Ltrim, rtrim,
rtrim,
find last, but1, whatever.
So let's say we wanted to add a rtrim to string method. In Groovy, you just go, oh, la, 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 I'm going to add a method in. And that is completely not type safe because how does your compiler know that these methods are being added into arbitrary points in the program, right? So Scala's approach to this is what you do is you create a class called enhanced string. And enhanced string extends string. Actually, it doesn't even have to extend string.
It doesn't even have to extend string.
So, but enhanced string has a method on it called rtrim. And that will, take a string, trim off the right side. And the enhanced string accepts a string in the constructor, usually. So it takes a string and it does kind of a delegate. So what the implicit conversion will do is you create an implicit conversion from a string to an enhanced string. Wherever you call string.rtrim, it will create a new instance of an enhanced string, call the rtrim method on it, and then return the result of that, all without you actually having to write the code. All you do is string.rtrim, and it magically conjures up a new enhanced string object, calls the method, and then returns it.
So, I mean, when you in Java, I've seen this pattern far too many times is, I don't know, you get something back from the commons collection library and you need to convert it to something else. So all over the place there's a to my string, to my collection, to whatever in front of the thing that you actually want, and that just clutters up your code. And essentially, implicit, well, functions in this case are just a way of getting the compiler to do this thing for you. If you have something and it doesn't quite fit, it looks for a way to basically apply a function to the thing to convert it to what you would need. And you don't see it. So it allows for a lot of glue stuff without cluttering up your code.
Yeah. Okay, so anyway, type-safe extensions. All right, so let's look at some code. You guys can all read that, right?
Yeah, so we're all software developers, so we should be used to reading small things on the screen. Right? So.
All right, so on the left is our Java application. See, we actually do have a Java version of some of the code. On the right is the Scala version. This is the UI code, and we actually, the Scala version, because you know, I use this funky brace convention where I put a brace on every single line. I think I'm breaking some Scala.
Well, you know, breaking. I mean, Scala goes back to some roots.
It's not very Scala-like.
Taking lots of braces out.
But you know, a lot less characters.
Yeah. So
almost half.
1,200 semicolons omitted. Something like that.
And let's take a look at what some of the Scala code looks like. So this is the application. For those of you who've done ScalaFX applications, this will look pretty familiar. You extend JFX app, which is the base ScalaFX class. I'm creating an instance of a model. We'll talk about the model in a sec. But here's the stage. That's your window, width, height. Create a scene. I'm using a stack pane for the top level and then setting a fill. So this is, you know, very basic stuff. And you notice the nice declarative kind of nested structure. It kind of looks like the user interface we're creating with the stage. The scene is in the stage, and then we're going to add additional elements for the foreground and the background as children of the scene. Loading an image is really easy. Here's the Java 1 logo popped off of a resource file. The image class is a reusable image object. The image view is what you actually put in the scene graph to display it. And the nice thing here is having that separation. You could have one image in multiple places, and it would only be loaded once. You could crop it, resize it, do different things with the images via the image view class, but then have a single image object backing all of those. Creating buttons. So we're going to have some buttons in the UI. I think I saw some buttons in our picture.
Yeah, I remember there were one or two there.
And that, you can see here, we have an action handler on the button, which is using closures. So we talked about Scala closures. So rather than having an inner class and a lot of code, we can simply have a small closure that on action is going to execute this code, model.filter, and then pass in the item from the drop-down and the text, and a clear, which clears the filter for us. It'll flush out the value in the text field and then clear the filter using the model method. So not a lot of code. This is actually, the slides are actually like most of the code in the application. We'll flip through it quickly when we show the demo. All right, and last bit of code for now is Scala table conversion. So this code didn't exist before, but the table implementation in ScalaFX didn't exist on Saturday. So you guys are seeing, at the JAX Conference, seeing the first implementation of a table view in ScalaFX.
You saw it here first, people.
Yeah, this is the cue to get out your phones and tweet something.
Tweet. ScalaFX now with table view support.
So if you notice, not only is it relatively short to write, you have your tables and table columns, and then you just hook it up with the list of speakers, and it automatically observes the list and pulls back data. But it's also type safe. So the actual fetching of values for the first name and the last name uses a function which takes a speaker as an argument and returns the string back from it, because that's the generic type of here. These are speaker to strings.
And for the non-Scala proficient people, the underscore is just an anonymous argument. So that just saves you from having to write s:speaker, speaker.first name.
So pretty
Bang, go another 25 characters.
Yeah,
something like that. Yeah.
pretty concise, and this avoids you having to, if you were doing this in Java code, you would need anonymous inner classes, very, very long generic definitions for all this stuff. The equivalent table code in Java is quite, well, verbose. So that's the user interface. We're going to talk about the database, but let's pause here for a sec. So anybody have questions about the UI code or anything we presented so far?
I think we need more coffee.
More coffee. I'm surprised they didn't bring like a little stash of coffee and
well, for us especially.
Yeah, for us.
Yeah.
We'd share though.
No, I know, we would.
All right, so we're going to talk about the database model next, and then finally clouds, and then you'll have a complete application. For the database, we used, as I mentioned, JavaDB Apache Derby. It's a good choice because it ships with the JDK. So if you have the JDK, you already have Derby installed. Very, very small footprint, 2.7 megabytes. It's standards-based, so you can use JDBC, Java, SQL, and it's very, very easy to configure. If you're on Java 6, JDBC 4, just dropping the jar file in your class path is enough to configure and set this up. So, very easy to use, and we're going to use it together with Circumflex ORM. This is one of the many Scala object relational mapping tools available. And the reason we chose it is it's a nice, convenient, short syntax for defining your model objects. Seems to have a very good community and several releases. They're up to 2.0 now. And there's other choices for doing ORM in Scala, but this is the one which we selected, and it's quite easy to use. All right, so Derby config. That's the Circumflex database configuration for Derby. We give it the driver. We give it the connection URL. The username and password don't really matter that much. It's a local embedded DB. And the default schema for Derby is app. If you don't put this in, then Circumflex does some funky stuff and you pull out your hair. So don't forget that line. It actually, I think it assumes the default schema is default, which is a keyword in Derby and causes SQL errors. Okay, and the speaker domain object. So the nice thing about the way ORMs work is you can use your POJO or plain old Scala.
Pozo. Sounds wrong. It sounds a bit too much like Hobo or something.
You can use your plain old Scala object, add a little syntactic sugar to it to define what your columns are, define your primary key, and your relation. In this case, where we have a self-referential object, which we can then use to refer to the different columns inside of our table. And this doubles as both the object we're going to use for storing our data, so our model object, and also our database definition. You can also use this to directly create the tables inside of Derby.
And note, by the way, as you can see up there, the string last name now has a function called varchar on it. So that is one example, most likely, of an implicit conversion going on there because obviously varchar is not one of those standard methods you have on string.
That's not in the Java string library?
I think it, yeah, it probably is in there. I don't know.
Maybe Java 20?
Java 20, yeah. But well, by then whether we'll still be using varchar is another subject for debate. But anyway.
All right, and then to query the database is very straightforward. So this is using the criteria APIs inside of Circumflex. So in the first case, we do speaker.criteria.list. That gets us all the speakers. You can also use a select style syntax as well. Circumflex supports a little DSL where you can do select speakers from table speaker, and that works as well. But I chose the criteria API because it's a little bit shorter and more fluent. And same thing, like in this case, we're doing a like query against it. So speaker.criteria.add, field like, percent, filter string percent.
And I'm guessing that's SQL injection safe.
Yeah.
Yeah. So if you do field like, drop, foo, drop table, app, whatever.
Yeah.
It will not work.
It won't work.
It's not PHP, folks.
Yep. Although you could do funky stuff with the filter string.
Of course.
Using the like syntax abuse. But
yeah, I know.
Yeah. And then you load all the speakers into filtered speakers. And if you remember from the UI code, the UI uses filtered speakers as the list, which it listens to for changes. Anytime we make a change to filter speaker, it automatically updates the UI. So we don't have to go and manually go to the table and change the results and update the UI. This just automatically binds it using the cool JavaFX observable lists. So that's it for DB. I mean, there's not a lot.
That's how simple the app really is. Let me just look at the
clicker?
Oh, well, I'll use the clicker. Yeah. So first of all, in the interest of fairness, I should say a big thank you to Steve because he's been very good and said we a lot of the times for things like the code, but it's actually him. So most of the code comes straight out of the amazing brain of Stephen Chin over there.
But I'm getting my payback.
So no, payback will come obviously. So
we're gonna post this on GitHub right after the event. So check out my blog, steveonjava.com, and probably JClouds will have it mentioned as well. It'll be part of the JClouds examples suite, and
that's when my payback time comes.
Andrew's gonna get full payback helping me do that.
Yeah, no, you can only push out the evil day for so long, but I mean it's coming in any case. So yes, obviously many thanks to Steve, and of course also thanks to all the JAX sponsors. Thanks for having us. All that kind of good stuff. Right, so the cloud part of this. So I guess there's a few things to mention here, and Steve mentioned a lot of these already. Cloud is awesome. That's really supposedly how it's pronounced. I always feel kind of bad when I have to say that. But anyway, we talked about these. Why is this interesting? Well, what are the 4 things that we're looking for here? We're looking for an on-demand service that you can kind of do yourself. You don't need a bunch of specialist consultants to get your RAID array set up in order to store stuff. It's scalable, obviously. Well, we're talking about 330K blobs, so we don't really have that much of a problem. But as Steve said, if you use the hashing algorithms, you can really get some very nice scalability out of here. And it's also measurable, so this is more where the cost thing comes in terms of pay for what you use rather than just paying a fixed rate irrespective of what you're actually using. So what's JClouds? Well, we discussed this a little bit up front. It's essentially a multi-cloud library. It's like JDBC for the cloud. Of course, there's multiple different flavors of offerings you have in the cloud, and we'll talk about those a little bit. But the idea here is to make it very easy from Java to talk to various cloud services and to give you full freedom around, do I want to stay relatively cloud agnostic in the same way as do I want to stay DB agnostic and maybe switch my backend database? Same goes for the cloud here, and of course, it's Java, it's a Java library, but it has a closure binding. There's a relatively large closure community around it. And thanks to Mr. Chin, we also have a Scala binding-ish thing, but of course Scala makes Java really easy to use anyway. It's tested across a whole bunch of different cloud providers. I think there's about 45 cloud providers in there right now. And that sounds like a trivial thing to say for an open source project, but you'd be surprised. Certainly out there in the cloud world, if you look at some of the other libraries around there, the amount of real serious integration testing that is done and can be done even is, how shall I put it? It leaves room for improvement. And yeah, there's a big community. In fact, well, this morning is a sort of testament to this community because we just had a meetup in San Francisco yesterday evening and I drank rather too much. So, if I start slurring my speech, then that is because of the vibrant JClouds community. So, in this particular talk, we're basically going to be looking at blob stores. Blob stores, it's just what it is. You take a blob of data, binary data, text data, whatever, and you store it somewhere. And then you get things like, you have a traversable hierarchy and you have versioning in some of the newer blob stores and so on. So that's one of the very simple things out there. They're generally not relational in the sense that you can't really filter or query them very nicely. And that's one of the reasons why in this architecture, we're doing that stuff using a local embedded database. But for storing data and potentially very large quantities of data, there's a lot of good solutions out there. I think JClouds now supports about 5 or 10 different blob store providers, ranging across a whole bunch of companies. Obviously, S3 we're using here, but Azure obviously has storage. Rackspace has some cloud files, HP Cloud, so there's a whole bunch of different ones to choose from. Compute is another big thing. Many more providers out there right now. That's about images, virtual machines, EC2, OpenStack, that kind of stuff. Boot up an image, run stuff on it, boot up 5 of them, whatever. Load balancing, some other thing that's coming up. More and more cloud providers are now supporting a kind of load balancing API where you can say, I want to route traffic between my multiple clouds. There's a few networking things and so on. And yes, of course, as more and more providers start to offer features that are in addition to these 3, then yeah, the community basically decides what we end up wanting to add. We try to provide 2 choices. Let me just look at the time. I don't want to spend too much time talking about this. Let's talk about the Blobstore very briefly. This is essentially what we're going to be doing, very recognizable from any kind of interaction with any context-based thing, such as a database, for instance. But yeah, you basically create a connector, a context to the provider that you want to talk to. In this case, you're going to get a Blobstore API, and there you can decide whether you want to have an cloud-agnostic Blobstore API, or whether you want to dive down into the provider-specific API. Then you just do a bunch of stuff, and then you close the context at the end. So it's a nice closable pattern, which in Scala also works pretty nicely. And even Java 7 obviously will support Java. When is it? Auto, yeah.
Yeah.
Auto closable Java 7 supports this pretty nicely too. So you can cut some cruft out of your code doing that. There's I mentioned this briefly already. Basically, in the cloud world, there is a sort of distinction between APIs and the actual companies providing implementation of these APIs. Some of them started out as a single company thing, S3 being a very good example. It was originally a product, obviously offered by Amazon. And then a lot of other providers have come out and have basically said, we're S3 compatible, to the point where without it ever being ratified as a DTMF standard or DMTF or whatever, it's essentially an API. And you can choose one of multiple different providers that will give you S3 interfaces to interact with your Blobstore, and obviously AWS S3 is one of them. Google Storage, which is in kind of weird state right now, is another one. There's Scale Up, there's a whole bunch of different ones. So there's extensions to the S3 API as well. And that's one of the things JClouds tries to do. It gives you various, different options in the sense that you can say, I just want a base Blobstore. I don't really care what the provider is, and then your maximum portability. But obviously also you have a least common denominator type choice. You can dive down and say, I want a provider that gives me an S3 API. And then you can add things like, I want it to be in California, I want it to be in North America, I want it to be here, there, or whatever. You have a bunch of choices that will guide JClouds into choosing a provider for you. But of course, you can also drill down, right down and say, I want, US, West 1, AWS S3. I think that's pretty much what we're going to be doing as well here in this one. So this is just the code version of what we discussed right now. You create a context at the top. Here you see we're selecting a specific provider. There's also, this is Scala. There's a type-safe version of doing this as well if you want to do that. So you pick the provider metadata. There'd be a definition right up the top here, which would say something like provider metadata equals AWS S3 provider. And then you say, well, I want to log in using, these are my credentials, and you can get them from a properties file or whatever. And then in this case, from my context, I want to have a Blobstore context, which for AWS S3 is pretty much one of the only things you can get. You can't get a compute context from AWS S3 because it's obviously a Blobstore. But if this were EC2, then you would get a compute context or something like that. Then we do something with it. So you can see here we're getting a Blobstore API. There are 2 types of APIs for all the JClouds things. There's a synchronous and an asynchronous API. So obviously this is the sync version where if you make a call, it'll wait for something to come back. The async one does what you would expect. It makes a call, gives you a future, and then you can either ignore the result or you can decide to wait for it or check it at a later stage. And then here we're just downloading a blob from a specific location and then getting the input, and I think that returns a input stream. And then you close it at the end. So not too many funky things going on in there. Just going to skip through some of these before we get into the demo. Well, obviously we talked about portability. There's some interesting gotchas there in the sense that a lot of people claim to have, for instance, S3 compliance, but that only ever goes so deep because, of course, Amazon decides to add a new feature to S3, and then there's this couple of week/month lag where people try to catch up and say, oh no, we now support this as well. Obviously, why would you use JClouds over just using the native SDK that ships with Amazon. You can download the Amazon SDK and use that straight off. Well, yes, but then you are definitely stuck with Amazon. And some of these SDKs are pretty, well, I can say this quite honestly, they suck. They're badly written. They're not very good. There's something about threading and then being enterprise grade here, you know, making sure, for instance, in Blob Stores, if you do a multi-part upload, you can write all that code yourself if you want, split it up into chunks and decide, but you can also use one of the JClouds abstractions, which is just a blob map, where you just put 10 things in a map and then say save, and it'll basically create a thread pool behind it, do parallel uploads of all those things, wait till they've all uploaded, and then give you the results, something like that. And then, yeah, well, then we talked about performance. There's a bunch of tuning options for, you know, tweaking the pool sizes, tweaking the timeouts, tweaking the backoff policies and that kind of stuff. Plus, you can run on the GAE, which is not necessarily a huge concern for a lot of people anymore, but some time ago that was a big thing. You can use it in OSGI if that matters to anyone whatsoever. But more interestingly, there is an integration with an OSGI container called carafe, Apache Carafe, or carafe, which has turned into a very nice command line interface for doing operations on your cloud accounts. Basically, a nice command line to start instances in EC2, start instances in Rackspace, HP Cloud, get your blobs, list your blobs, all that kind of stuff, which is nice to have across a whole bunch of clouds. We talked about the closure binding. There's the synchronous, asynchronous split, which I can proudly say was something Adrian, who's running around, I think, outside somewhere, the father of JClouds, if you like, invented, and has then been copied into a lot of the SDKs that the providers themselves ship. And yeah, we run a bunch of quite expensive integration tests sometimes, to the point where actually there are some providers who say that, you know, for them, the definition of whether their cloud works is when the JClouds test pass, which is definitely the wrong way around. It shouldn't be that way, but that is the way it is. I talked a little bit about location metadata. That's a really interesting thing, and that's sort of a bit of a 2.0 use case to some extent. For a lot of people, they just want something to be stored and they don't really care where it is. But you get a whole bunch of, you know, you get the disaster recovery use case. I want 2 copies of my data to be stored further than so and so much apart, because if one data center goes down, I have a recovery option. You have the option where you say, well, for legal constraints, my data can't leave a certain geographical location, which if you're working for the state of California, means that you can't store your data outside California. And so all these things kind of play a role. There's more metadata things. There's speed and how fast is the network connection to this thing, because that has a performance impact and so on. So JClouds does a really nice job, I think, of, first of all, exposing this metadata about a whole bunch of different providers and then giving you the ability to query it and do clever stuff based on that. I talked a little bit about the multi-part stuff. Yeah, you know, it's not fun to write, and it's not fun to test, and it's something that's stupid if you have to do that yourself. It's like trying to write your own sharding when you do a database algorithm. And yeah, of course, community is a big thing. We have a whole bunch of committers with drinking problems, and no, there's a lot of big companies involved as well. I mean, it's not
catch them later for some good drinking.
Yeah, there's not just individual startups, but there's also a lot of the big providers. HP is contributing to the effort, so a lot of their HP Cloud stuff works on here and so on. So it's a fun place to be. So with that, I will hand the magic wand over to Steve and
so
demo time.
Yeah, so we've managed to not actually show any working code this whole presentation, so that could be a good thing.
Yeah, but you just trust us, right? Obviously.
High level of audience trust, or it could be a problem because maybe some of this stuff doesn't actually work.
Maybe the cloud is down, which never happens except last week, and then sometime before then, and then sometime.
Yeah, big Amazon admin. So some of this is the ScalaFX code. You can ignore that, but the code right here. So conference model, conference UI, DB utility, JCloud util. That's the actual application code. And that's it. About 4 files. Not that much code.
Not IntelliJ, still required for Scala development to a large extent, despite TypeSafe's best efforts to make Eclipse semi-performant.
So if you look here, this is the conference UI class, and it's you know, same thing I showed: basic application structure, loading an image. I have a little rectangle here just for visual flair, and then the buttons I mentioned. So filter, clear, reloads an extra button. I didn't have it on slides. And our table. So, exactly the same code you guys have seen. This whole file is...
We'll probably save another 8 characters by removing the function call around company and these things, because I guess they're read-only.
I can do
But let's not break things. Let's not touch it. But just to say, in Scala, you don't...
Oh, no. So that is required.
Oh, that is required. Whoops. Go hide behind the...
It's a...
He'll explain it to me later.
It's a circumflexism.
It's a circumflexism. Oh, okay. Because in general, if you're not using circumflex, then of course in Scala you can
leave off. You can leave off.
The convention is if something doesn't have side effects, if you're just getting a value, you shouldn't care whether it's a method producing the value or whether it's just a field that you're reading. And in fact, unlike in Java, fields and methods share the same namespace. So in Scala or in Java, you can't, or you can have a field and a method with the same name, and obviously by adding parens or not, it decides which one to call. In Scala, if you need a value last name, which is defined as a string, you can actually implement that value using a method called last name that returns a string.
Okay, and then if we look at the actual speaker class, what we showed in the slides. If we look at, what else have we got here? DB utility?
Not much. Yeah,
there's not much
code.
code.
It's just far too small.
Oh, actually, we don't even use this code. This code was a one-time load of the database in the cloud.
Okay.
So that's not even used.
Oh.
Yeah, that's about it. And then we also have the JCloud util class. I'm not going to show that class just because it has my Amazon S3 keys in it right now.
So,
but I'm going to strip those out when we post it to GitHub, so it'll all be good soon. Yeah. Okay. So that's it, and we click run and we cross our fingers.
Is the cloud up? Stuff is happening. Ooh, warnings. Oh no.
No,
that's
good.
Those are joke warnings. They're meant to happen. Warnings are meant. No, wait, no. And then,
there we go.
Big round of applause, at least from me. Very cool. And so you want to talk us through some of the bits in the UI?
Yeah. So this is a table view, and it shows all of the guys. You can actually adjust columns. Just drag and drop columns around, resize stuff. Try not to crash your user interface. Filter. And
filter. Oh, the gremlin is back. What did you do, Steve?
I blew up my.
You blew up the UI?
I blew up the UI.
Okay, well, let's try it again.
Let's try it again.
So, for the video people there, that never happened. Now we show it again.
Edit points.
Yeah,
edit start. Edit cut point.
Edit
stop.
Cut. Right, let's do that again.
All right, let's see if we get a.
Let's see if it gets any better.
I was just showcasing the fast startup time of the application.
You were indeed.
Yeah.
And now we're.
Let's see if we have any. Wow.
Uh-oh. See, this is
engineers.
The fun thing. No engineers? Steve! It's fun. This is a nice one. Yes, it does work sometimes when you are not looking. Yeah.
Just like a demo.
Just like a demo, the way it's meant to be, right? It's like a customer demo. Initializing pool, use traditional equals false.
There's no errors.
There's no errors. Oh, well, whatever. But in any case, so you can see the buttons, obviously. So the 4 filter buttons, the clear buttons, the reload buttons. I guess the thing at the top is the image that you were loading. I am talking to keep the crowd occupied while Steve types stuff and tries to reload it again, and he's wondering.
All right, so third tries the charm. Let's try it one more time.
Let's try one more time? Let's try one more time.
time.
Ooh, fast UI startup time.
We're showcasing the fast UI startup time.
Yes, for the second time. Another edit point. So,
all right,
Chin,
so the way it's
find
supposed
yourself.
to work.
It says there.
Well, her first name is not going to be Chin.
Yeah, no. Okay.
Filter?
Doesn't work.
Doesn't work.
That's fun. I wonder what happened. Anyway, well, I know that when he showed it was probably the coffee that I had this morning that made it.
Probably.
In any case, that's why we have some homework to do. But Steve's looking through the code. I wonder what it is. Should we try and load it locally? Maybe the cloud is down. Maybe, what's your wireless? Your wireless looks okay.
Shouldn't affect.
So we can blame it on the cloud. Let's just try it anyway.
We'll try anyway.
The
local version uses the zip file you see here, SQL.zip, and loads it from there instead.
So this, of course, should not make any difference, but probably it will, or not. No, it doesn't. Oh, well.
It doesn't. It's a UI thingy.
It's a UI thing, yeah. That's a good thing. I'm a server-side engineer, so I can always say, as usual, oh, it's a UI thing. And today is no exception.
It's a good thing. It's a good thing Andrew prompted for the applause after the UI popped up the first time.
Nice.
And we're gonna post the code on GitHub later
Eventually.
on. What? So you
No.
guys can spot the error. No, actually, we're gonna post a working version on GitHub.
Yeah. Anyway.
But essentially, the functionality is you can choose any of the fields from the dropdown, and then you can filter. If the filter button actually worked, you could actually click and filter on those. It looks like the buttons actually aren't firing.
Can you show where the dropdown is populated? Because I'm just wondering, because that's always one of the
Oh,
things
actually, this is cute. So
I find really annoying.
the dropdown actually uses the model object from Circumplex. So we refer to speaker.firstname, speaker.lastname, put those in a buffer.
Yeah.
And that actually populates the menu.
Okay. So, but if you add a new what am I trying to say? If you add a new field to speaker, you would have to put it in there. Add to the list. Okay.
But it's all type safe.
Yeah. That's a start.
Okay. So if you guys would like to contact us, we didn't have this on the first slide, but you can feel free to send us emails directly at stephen.chin@oracle.com or andrew@jclouds.org. Feel free to hit us up with questions if you have it about the technologies we showcased, Scala, JavaFX, JClouds,
Filter buttons.
Also, follow us on Twitter. We'll both be posting later today once we get the code uploaded to GitHub, so you can try it out yourself. And we're going to do a full, I think we'll probably do an SBT build for this. So you just be able to command line deploy the entire thing with all the Maven dependencies and go for it.
You'll be able to see what life is like when somebody tries to reinvent a build system. Hello, right, SBT. I like you too. Anyway.
Yeah, I don't. All right, so thanks for coming.
Yeah, thanks very much.